Net Zero 2050. Sustainable initiatives to be taken by the textile mills from the energy point of view. This I have presented in the Textile Association of India South Zone Conference at Coimbatore in November last month. I just wanted to have a detailed discussion about this in this presentation. Thank you. So, energy saving basically it's a collective responsibility of all the members inside and outside the mills. So, the sustainable initiatives related to energy conservation and efficiency by proactive workings of maintenance, production and the quality inside the mill. So, each and everyone have to work together to have an excellent quality, at the same time maintain the production more and give respect to the maintenance also inside the mill. This collective responsibility needs to be there in all the departments to optimize the units per kg of yarn production, at the same time reduce the units and increase the yarn kgs. Then comes the stakeholders. Apart from the mill, inside the mill, what are all the stakeholders is the utility machine OEMs, the mill users and the supporting associations. Let us say many of the associations that are there that is supporting the mills, they need to work together to share the communication in between the mills about the textile working parameters and each and every machine, each and every department in the utility and in the production. It is for knowledge sharing in between the mills. The associations can do an excellent syncing work and definitely it will be a win-win situation for the mills as such. The intercommunication between the shareholders about the energy efficient parameters adopted in the next mills, it is a good knowledge sharing for each mill as such. As such, the estimated energy saving potential as per the TERI reports, it's old but still it's around 23% for the decade old mills, and many mills have already reduced and already they have done it, but still there is a good scope for energy saving here as such. So, the steps to reduce the energy consumption. The energy savings and energy efficiency is towards the reducing the carbon footprint for the given mill, first by monitoring through the ENMS. This ENMS is becoming mandatory for the mills now, textile mills now. Then comes the reduction of T&D losses. This is where I find lot of input related energy losses are addressed to, but the output flows that needs to be addressed in the mill. The transmission and distribution losses are there in the mills in the compressed air pressure or the static Pascal, either in the WRS or in the pneumafill or in any of the parameters, the temperature and RH, especially in the air conditioning plants, all these are addressed here so that the T&D loss is brought to the minimum. Let us optimize it as such. So, next comes the, let us discuss with the OEM, each utility OEM, though they have supplied their machines maybe 5 years back or 10 years back, still let them give the inputs, the efficiency details of the existing efficiency details of the machine or the utility and how this can be automated. Then comes the reduction of intermediate power transmission systems. This is again, there is a loss of self loss is there in many of the intermediate transmission power losses. This can be addressed too. Then comes the improving the infrastructure to increase the green cover surroundings of the mill. In the maintenance aspect, changing over from time based maintenance to condition based maintenance, and that too from preventive to predictive monitoring maintenance, this is needed, this is the need of the hour, and that's we have to do it now as such. Let us study the intermill and the intra-mill comparison of energy consumption parameters of the input and output flow of the utilities both in all the aspects, then come to reduce the energy consumption of each stage of the mill side as such. Let us visualize the energy losses in our existing subsystem. Existing system, subsystem, intermediate power transmission components everywhere. Let us monitor the energy consumption at the input, output and exhaust of any system as such. Bureau of Energy Efficiency always says, always monitor the energy consumption of any of your machines above 5 HP and then target the energy reduction. So, First stage of energy conservation can happen is trimming the input parameters to suit to the process. Then comes optimizing the intermediate self consumption in the power transmission between the motor to the machine. Then coming to the nameplate efficiency, let us try to restore to the, always let us look into the nameplate efficiency of each of the utilities and let us see whether it is matching to the production requirements and where is the gap and how to address this. Let us try all the zero and low cost measures first, and then let us plan for if all the energy conservation measures are done and still there is a heavy scope of energy saving is possible, then let us think of replacing the utility with an energy efficient version which can reduce your energy consumption at the input. Also it can enhance the output, productive output also is more as such. This increase in output of the product, that is more important in especially in replacing this existing energy consuming devices as such, equipments as such. In general, the energy intake for the given textile mill, the energy losses happening between the cup and the lip inside the textile mill. The voltage regulation means all the EB related transformers, they are all rated for 11 kV or 22 kV or 433 only. But the mill needs only 390 to 400 volts only, let us say around 400 volts. So in stages, voltage regulation needs to be done. OLTC has to function in some of the areas, the servo stabilizer has to function in some of the areas, some of the equipments I am trying to say, the voltage regulation is very much needed in each and every department of the mill. Then the power factor improvement. Thanks to Bureau of Energy Efficiency, the lot of power factor discussions have already taken place, guidelines have been given to the energy auditors and energy managers that from the equipment side it is maintained around 0.8 by the load and compensation capacitors, around 0.9 at the SSB and around 0.98 at the EB incoming side. The harmonics reduction also at the equipment end, let us try to have the line reactance chokes at all the VFDs. See to it that the harmonics say around 30%, it is reduced to 15%, half the harmonics is house arrested at the VFD input itself, and then at the SSB let it get detuned, and at the powerhouse see to it that at the incoming it is less than 10%, what is stipulated by the existing EB norms as such. On the compressed air deliverables, this compressed air needs to be cool and dry from the compressor after the receiver at the compressor house until the machine end. This compressor needs to be cool and dry. Let us try to ensure that. See, these are all the parameters, these are all the energy influencing parameters in the utilities that needs to be looked in. Coming to the AC plant, the moisture ingress has to happen in stages to the yarn of the main product of the mill. This temperature and RH in each and every department has to be kept correctly. At the same time, no hot pockets are there in the department. This is also to be ensured so that the positive cross ventilation definitely needs to be there as far as the humidification plant is concerned. Coming to the waste collection, optimized suction Pascal in stages. Let the machine deliver around 1600 or 2200 Pascals from the blower end. But what is needed at the card is around 600 Pascal means if you are keeping around 1000 Pascals at the header near the card, almost you lose around 20 to 30% of energy loss because the static pressure is more by 20%. If the static pressure is more by 20%, the power loss, kilowatt loss or the energy loss is around 33%. So let us try to concentrate on the static power, static Pascal in each and every aspect of the mill, and let us try to improve upon it. Wherever the energy that is measured digitally and accurately in stages, definitely this will try to go in a big way to reduce the consumption of the mill as such. The energy parameters to be optimized at the tail ends first, that is more important, and next to the load ends. First the mill has to see to it that what all the power factor improvements has done up to the SSB or up to the powerhouse incoming side. Then let us have the 3CT controlled APFC to maintain the power factor at 0.98. Also this will reduce this power factor at 0.98, precisely at 0.98. Why I am insisting here is, if you go more and more to unity power factor, this leading kVRH, this increases the unstable voltages at the incoming side, and also the THD and the TDD, total demand distortion in the harmonics also it happens when the power factor goes more than unity. So let us try to maintain it 0.98 exactly, precisely. Then coming to the non-linear loads, let us the line reactance choke needs to be fixed at the VFD incoming. Let us discuss with your VFD OEMs, whatever the DC link choke they have given it, that is not enough for the mill as such. The AC line reactance choke has to be mandatorily fixed on all the VFDs, so that at least from 1/3 to 40% of the harmonics can be house arrested at the VFD input itself. The end-to-end voltage drop, see in many places they say it is around 6 volts, it is around 5 volts, this is around 10 volts, more than 10 volts. Let us try to have a high-low voltage relay at the sensing relay at the tail end of any of your load end machines. Wherever the alarm comes, let us try to see why the voltage drop is happening intermittently and what to be needed to correct that as such. The compressed drops also, many of the mills lose more of pressure loss by more than a kg at the compressor hours itself at the dryer. So it needs to be from end to end, it's around 0.3 kgs only is normally allowed norms. Let us try to reduce the pressure drops across the dryer, across the compressor, from the compressor to the compressor to the mill. Let us try to, at the tail end of the mill, let us try to maintain it around 0.5 kg only. All the ducts needs, the textile mill, because lot of fluff is there apart from the yarn, the ducts gets totally getting choked intermittently. This needs cleaning routinely, and if the ducts have gone bad, especially on the humidification ducts, because of water ingress in the air, this needs to be replaced, and the material of construction also matters here, and the orientation of the duct also matters here. But always the ducts needs to be tapered from the supply end to the delivery end, so that the static pressure is maintained throughout the duct from the supply end to the delivery end as such. The AC plant, definitely it needs to have a higher static Pascal to deliver airflow at the fan end as such, at the equipment end as such. The VFD has a versatile options, and the utility machines, utility applications we have not made use of it. In the production machines it has been made use. Thanks to all the VFDs that is coming in the production side, the mill mill manager definitely goes for VFD as a flexibility for the operation as well as for improving the production to the matched required demands on the day or the week or the month. But in the utility side, we find the VFDs are fixed. It is like only operated manually, only on hertz only it is operated. This is not at all enough for us. This needs to be on a closed loop control. The automation needs to be there when the VFD is there, and if this automation is done on the VFD on any of the process parameters inside the mill, on the utility parameters, this will give an excellent energy savings, and you are trying to make the parameters, utility parameters precisely fixed, and there is no variation in the utility parameters, and definitely this will give enormous savings to the textile mills. The static pressure controls in the WRS, in the autocorners, many people are operating still at 4000 Pascal or 4500 Pascal, where around 3000 Pascal can be maintained also depending on the count. That is also matters here. The comber or the compact, the compact on the ring frames, you can see almost a straight length of pipe up over a fixed size only, fixed dia only. But what is needed is a tapered dia from end to end. See, 150 feet of line size is there, and this needs to be tapered. Both the pneumatic duct needs to be tapered and the compact duct needs to be tapered in such a way that the static pressure is maintained end to end as such. Coming to the plant temperature and RH for the given plant, this also needs to be in closed loop control. It can have a band, but definitely the closed loop control will definitely help for the mill as such. The water pumping pressure, that needs to be say around 1.5 to 3 kg, but still VFD on a water pump pressure control definitely helps to increase the spray dwell time of the water mist inside the AC plant, so that you can maintain more than 95% of the RH at the mist eliminator, and definitely this is carried over to the mill side as such. So VFD is also needed for the carding cylinder motor, where well carded is half spun, and smooth carding definitely will help you to maintain a smooth speed, and definitely the efficiency of the carding machine also can be improved by retrofitting the VFD here. The simplex control loop is like a ring frame where we have the camelback DOF pattern operation. So simplex also it needs a VFD to have a speed control, and that also can be done as such. Basically, the textile mill needs the air at the right flow and the static pressure to comfort the machine, to comfort the process and to comfort the total mill operation as such. The spinning operation demands for right mix of moisture in water in stages, the misty water in moisture in stages. The whatever that is delivered at the AC plant, that needs to come to the mill and not with much of drops in between, and definitely each and every department can function within their temperature and humidity norms. Definitely the mill can have an increase in productivity. So it's basically an air operated industry. The water has to be increased in stages only to improve the quality of yarn also, or the mill productivity also goes up. So the static pressure to be optimized if the mills want to really achieve energy savings and sustainable energy savings. That's what we are more interested. Over a period of years, many years, say 10 years or 20 years, we have to maintain a positive cross ventilation inside the mill. Here the textile associations can share what are all the customized Pascal values for each and every department, for each and every machine, for each and every utility, and this will be a win-win situation for all the mills under the association umbrella. In general, for any given mill, if you see the breakup of consumption, electricity consumption, let us say around 100% is the electricity consumption, and what are all the utility consumption is there, around say 10% on the AC plant, means that needs to come down by half. If the compressor consumption is around 6% or 8%, that needs to come down to 3%. Like that, all the utility percentage in the mill electricity percentage has to come down by half its level by improving its energy efficiency levels as such. Here the OEM plays a crucial role. He has to give the efficiency details of their new machine as the existing machine already supplied to the mill, and the efficient loading also. This efficient loading is more important here. See, what all the machine OEM can give is each subsystem efficiency and how it is matched to the production and utility machines. The utility OEM plays a major role, and he can give a lot of inputs how to reduce the energy consumption for the given mill production pattern, and how on the compressor side, on the pump side, on the blower side, on the AC plant phase, everywhere it can be done. The energy conservation is possible with the active discussion with the OEMs and the energy management professionals like energy auditors and energy managers. And definitely the energy audit also is calls for in each and every mill. Thanks to the Bureau of Energy Efficiency through the PAT cycle, they always suggest each mills to go for a 3-year PAT cycle. Let us not go by perform, achieve and trade, but let us try to do a 3-year audit cycle to reduce the consumption of each and every department electricity consumption, energy consumption, and reduce the overall units per kg. See, if you take the case of a motor, the OEM talks about part load efficiency, need to talk about the part load efficiency of the motor at 25, 50 or 75 or 100% in graph and figures, because the mill can operate a coarse count or the mill can operate a fine count, and each ring frame can operate from 30% or 20% to 80% also. So, in that is the case, the motor efficiency also matters more, and that needs to be given by the motor OEM. Coming to the compressor OEM, he needs to give the what is the kilowatt what is the CFM deliverable at what compressed air header pressure, and what is the kilowatt consumption as a compressor package. And if it is a blower, the blower has to OEM has to give the fan performance curve, what is the CMH, what is the CFM deliverable by the blower at what static pressure. That is more critical here. The compressed air flow is talked in terms of compressed air header pressure. The blower flow CFM is talked in terms of static pressure only. At static pressure, at compressed air header pressure, at a given temperature and RH, how the AC plant is maintained. All these things are important here. So, let us see the positive cross ventilation is maintained inside the mill, and all the centrifugal blower impellers, what all we are using in the mill, either in the pneumafill or in the WRS or in the comber or in the compact, whatever it may be, this needs to be aerofoil. See, we have tried this application, this aerofoil impeller in our pneumafill, and it gave an excellent savings of around 20%. This is always possible in all the other blowers in the mill, and till now the mill has not concentrated in replacing their impeller to energy efficient impellers. It is a welcome change that needs to be done as such. Still there is a scope for optimizing your fan and water circuit, improves the air and water efficiency at the generation and at the right mix later. All the mills are designed, the AC plant is designed for the peak summer condition, and the VFD becomes a mandatory for the AC plant. The VFD has to function in closed loop automation for the given mill for the given time, either it's in the peak summer month or in the winter month or in the lean months. VFD needs to be mandatorily be closed loop operated instead of manually operating the hertz of the VFD. Now, I am trying to say, let us try to rethink axial flow fans. It is operated directly. The motor is coupled directly to the fan, and previously, decades back, it was only belt operated axial flow fan with a cogged belt and resized pulleys. Definitely it can give an energy savings of 10%. By adjusting the torque that is delivered by the motor, that is optimized to match to the demand that is demanded by the axial flow fan. This the mill can take up it's a point to ponder. Definitely the mill can take up this way as such. Coming to the two fans fixed in each AC plant department, let us try to have a partition and let it have a conjoining duct to the main plenum duct. If two fans are kept in the same they are short circuiting, and definitely the fans get derated also due to short circuit. The AC plant supply also needs to be cool and green covered with smart bricks. Water ingress to be there at the suction of the supply fans. It is monitored and controlled, and definitely controlled to utilize the ambient wet bulb temperature. The solar heat loads are there throughout the mill, so definitely the attic ventilation plays a major role especially in all the textile mills. You can definitely go for attic ventilation, provided all the ducts are insulated above the ceiling and above the attic condition, and definitely you can see to it that the solar heat is almost 50% heat is getting ingress into the mill side, that can be removed, at least partially removed. The mill needs a green cover around so that it serves as a canopy and viewed from a drone as such. Coming to the intermediate power transmission losses in belts and pulleys, that is happening now. Say the mills are concentrating on the electrical input kWh only, or the speed drop or the mechanical torque drop in the ring frames. But what we have recently observed, not recently, for the past 3 or 4 years, we find the existing flat belts or the timing belts or the variator versions, they are consuming more because of their self consumption. The mill can definitely give you a try for the cogged belt and resized pulleys in their VFD operated ring frames. Definitely it gives a savings of minimum around 2% energy savings, and in some of the mills having done this cogged belt conversion, they are able to raise their RPM by 1000 RPM more. Say instead of 21,000 RPM, they are able to raise 22,000 RPM by changing over from the existing flat belts to the cogged belts. That also can be tried. It is a recent innovation, and definitely this intermediate self loss needs to be avoided in each and every mill. The rugged cogged belts, which are all polymerized, it reduces the self loss, the power carrying capacity is more, and definitely it will be a win-win situation. The nuisance or lot of losses are curtailed or controlled here as such. More than everything else, the vibration, the predictive monitoring for any of the machine, especially the ring frame, after doing this conversion, once the vibration is studied, you find the vibration has dropped drastically down. Coming to the lubrication of all the motors in the mills, the mill has taken an excellent lubrication schedule for all their production machines, but all their motors, they are still operated with lubricated with multi-purpose grease only. This can be changed to specialty lubricants like polyurea thickened mineral complex grease, where even the imported or the MNC motors, they also suggest for a 3-year greasing interval. That definitely gives a energy saving and a smooth running of motor, and the heat dissipation is there from the bearing end to the motor skin as such. The motor skin needs to be warm only, it cannot be hot inside the mill. Once it is becoming hot, it is a silent energy loss that is happening inside the mill due to the motors. But actually many mills are over-greasing their ring frames with their ordinary grease. Ultimately the temperature or the kilowatt consumption definitely increases. So the mill needs to be aware of that, Let us give right size of greasing and right quality and the quantity of greasing as such. Optimizing the water, lighting and air changes parameters decide the energy efficiency at the mill. As I said, the water circuit, this can be made like a ring main circuit in the AC plant, in the humidification plant. Instead of all the radial type vertical risers standing alone, that can be combined and made it as a T connection, and it can be made as a ring main circuit, so that the overall water pressure distribution, the pressure can be reduced, and the spray dwell time of the water inside the plant, inside the mist eliminator, can be increased upon. The water needs to be operated at a lower optimum pressure only. Then comes the LED lighting. LED lighting, almost say 99 out of 100 mills have changed over to the LED lighting. Excellent. But they maintain the luminous efficacy of the LEDs and as well to elongate the LED tube light useful life. Definitely mill has a lot of spare servo stabilizers, or if you don't have, you try to buy a new servo stabilizer, especially for your MLSB, and this gives an energy savings of 3 to 5%. Definitely mills have done that and they have shared their inputs to us as such. So the mill manager must accept only one thing: energy saving is not possible in the utility machines if they have inherent defects, if they have defects inside their machines. So first clear the defects, clarify, remove the defects, and then only preventive maintenance let us do it. And see, many of the defects crop in because of wrong insulation. If you see many of you 7 out of 10 textile mills, all their compressed air exhaust duct is not there. It needs to be there, and it needs to be expanded duct, so that the compressed air, the hot air that is exhausted out, 70% of the hot air that is exhausted, that needs to come out of the compressor smoothly as such. So the ideal industries definitely look for reducing their carbon footprint. Let us try to let each and every textile mill reduce their energy consumption and reduce their carbon footprint as such. Why I talked about the VFD related to the production machine, and what is to be seen in the VFD as well as in the parameters, the ENMS parameters in each of the production machine, especially the ring frames. You can see the kings in the zigzag in the kilowatt because of the jerks or the static friction, or the friction components is more in the machine, the lack of lubrication and lack of efficiency, the transmission efficiency. This can be addressed by only monitoring like this type of graphs for each and every machine. Apart from your production UKG, this also needs to be seen in each of the ring frames as such. Citra always says the energy consumption of the ring frame almost 20%, thanks to Citra for this giving this real input, a practical statistic. Almost 20% energy is lost, is consumed. I don't say lost, it is consumed between the tin roller shaft around 12% and at the motor around 8%. This needs to be addressed to, and once it is wherever the self consumption losses are addressed, definitely this can be brought down from 12% to 6% and from 8% to 4% for the given motor. So overall, the 20% the energy consumption norms can be brought down by half to 10% by doing the reduction in self consumption losses. So the motors can be effectively, efficiently utilized for better energy savings, provided they are operated at right loading around 60 to 80%. Coming to the ring frame, we are not able to go for more than 60% due to the torque constraints. Any motor power is a product of torque and speed only, and definitely the ring frame needs to deliver the power at the full length of the, or the entire length of the tin roller shaft to the spindles, say around 150 feet, around 1200 spindles at the length of the machine. Definitely this logical reasoning calls for, logical thinking calls for relocating the motor at the center of the ring frame, and the motor can deliver a balanced torque at both the ends of the motor at an efficient speed more than 60% or around 80% as well at an optimized pressure. The loading also can improve and the optimized power consumption can be there, and definitely the deliverable or the productivity per ring frame can be increased by repositioning the motor. It is an idea only, it is a first thought. Let us discuss it, let the OEMs discuss it, and let us see what are the future options that is there possible as such. Coming to the pneumatic duct or any of the ducts that are used, see the WRS ducts, you can see what all the duct size taken from the plant, from the WRS plant to the machine, carding machine, it is tapered. So similarly, let us try to have a tapered ducting for all the pneumophils, for all the compact systems, all the converses, wherever that is possible, the ducting has to be there. That is what we learned from the HVAC norms as such. HVAC ducting patterns calls for A1 V1 is equal to A2 V2, where the area and the velocity is maintained so that the static Pascal is maintained throughout the duct as such. Coming to the motors, throughout the industry segments, all the other segments have gone for TEFC motors for the IE3, IE4 and IE5 versions, but our textile mills are still using this TENV motors, non-ventilated motors, where the motors are getting heated up gradually, and sometimes accelerated heating up is known, that accelerated aging of motor also happens. So definitely a hard skinned motor is a silent loss to the mill. Let us see it, the motors are, skin is not hard, it is only warm only, and let us try to dissipate the heat from the motor to the surroundings and keep the health of the motor sustainable for longer years as such. The intermediate power transmission loss from the ring frame to motor, the spindles, that is what I was talking about, coming from the main motor to the bells to the pulley sizing to thin roller bearings to the specialty to the jockey pulley and spindle tape and spindles up to this total chain of transmission, the savings is possible around 2 to 3% by going for the specialty lubricants here as such. Let us learn from the life cycle costing, especially when we are buying the energy efficient utility buying. The textile mills always look into the initial cost when you buy a utility machine, but when you buy a production machine, you go for a higher price, you go for a higher productive machine, but when you go for a utility machine, you always look for a excellent efficient machine where the first cost is only around less than 10%, but the energy and maintenance cost is more than 90%. So the mill manager needs to give priority towards the energy, the total life cycle cost of the utility machine, that is to be matched to the production schedules as such. So in general, the energy conservation plan for any of the given mills, we can save energy and maintain the energy savings sustainably so as to improve the health and the productivity of the mill. The energy conservation plans in the given mill, definitely it improves the company's annual targets, the process optimization, technology improvements, market competitiveness. This is more important to us now. At this moment of crisis, the market competitiveness is more important. How to improve the OPM, operative profit margins, that is more important here as such. Energy conservation is always a low hanging fruit, and definitely it is still left unplugged only, not only in the textile mills, in any of the industry. So if you want, see, it is silently eating our operating OPM as such. You are spending almost 4 crore rupees to install a 1 megawatt solar, and you generate around 5,000 units, electrical units per day, but you spend less than 1 crore only in this energy conservation exercises, and definitely you will get this, you will retrieve or you will recover these 5,000 units, you will reduce these 5,000 units, and you will be delighted to see your energy savings. If your power bill is around 10 crores per year, you can save around 10% through better energy monitoring. Energy monitoring is a must, then only the control can happen. The control and the energy conservation practices can happen through condition monitored maintenance approach. So you can just ask yourself how much yarn you can sell to earn this 1 crore net per annum, because the inside around 10% energy loss is already happening. This can be recovered from the inside of the mill itself. This 1 crore is within yourself, in your premises, and it is time to retrieve that now as such. All these energy conservation exercises, the case studies, everything I have explained in this textile mills energy conservation and management, as well as the bells and pulleys conserve energy and sustain the productivity of the machines, and the energy savings in the compressed air utility systems. In all the 3 books I have explained with lot of case studies. You can definitely go through it and implement the energy saving case studies, and if you have implemented and you have achieved the energy saving, kindly please share to the other mill peer engineers and the counterparts. Everyone, let us be benefited. Let the textile industry reduce the energy consumption in overall, and is benefit for the textile mills as well as for the nation. Thank you, thank you, thank you.